Hello, YouTube. Hello, YouTube. This is Vaz from Los Angeles. I hope everyone is doing great. Today, we're gonna review SOXL, our favorite uh, 3x leverage ETF. Also, we're gonna see why some of these indicators to basically trade based on that, those are useless, like a MACD. We're gonna mainly talk about that. So, quickly reviewing SOXL. Surprise, surprise, this week it suddenly went down, but 15%. Right now it's slowly coming back. I don't know why. Still, it's okay for me. I'm in the money. I didn't sell the um, my holdings, so far so good. But we want to talk about MACD and why is not a good option to trade based on that. So one of the traditional method to basically understand when the market is bull or bear is this MACD. Basically, you use this tool that is available in investing.com right there. Um, Indicators, you go, you select MACD, then you can choose that, and it has some tuning parameters like a fast lane, slow lane, source, signal length, etc. Regardless of how you tune that, first you see two two lines. They call it slow and fast. And whenever these two crosses each other, basically you need to take action. If the blue is top, it means the market in bull. If the red is in top, the market is bear. But regardless of how you tune this, you gotta notice that the peak when the market is going down and the point that these fast and the slow lane cross each other in MACD, they have a time delay. For instance, for this peak, for this particular MACD, it's gonna be, it happens at 21st of October, then a few days later, it shows up in your MACD. We want to talk about why is happening, why causes that, is it possible to solve, and how that can affect on other indicators. Okay, first, what is MACD? According to the investopedia.com, moving average convergence divergence. This is what the MACD is. Basically, what it does is take exponential moving average of your signal, desired stock, based on the uh, period that you decide. Let's say, for example, in this case, it says 26 days, 12 days. Subtract those, and it becomes MACD. So, what is EMA? Let's go more through this. EMA, again, according to investopedia.com, EMA is exponential moving average, meaning that it's kind of try to filter your desired signal. So let's recap. So MACD has two components of the EMA, exponential moving average. One is 12 period, the other one is 26. Then you subtract those. What is EMA? It's exponential moving average. What is it? Exponential moving average is a type of digital filter. It's a discrete time domain filter. It's under category of infinite impulse response filters. How do I know that? So the current state, which is EMA today, is related to the input signal value of today for that stock times sine weighted value plus EMA, the output value of the yesterday times some other weighted value. This, what is called infinite impulse. Infinite, it's because you accumulate, it's summation, yes? It's summation, there's a summation sign. You accumulate all the information from past with the sum weighting value. This is how you weight that value. There's a multiplier that weights. The number is going to be between 0 to 1, and that's say how much that past it's related to the today value. So this gonna create some sort of a low pass filter. A low pass filter smooths out the signal. If you go back here, you're gonna see your signal is kind of smoother. Yeah, this is it has a lot of noise, upside down, up, down, up, down, up, down. But your MACD, which is exponential moving average, it has a it's smoother than your actual signal. Why is that? Because you have a low pass filter. You throw out all the high frequency. However, that's come with the consequences. Consequence of the low pass filter, it's a summation. We are doing the summation every time that you do something, you are adding stuff, you accumulate, and it's delayed the response to the changes. For instance, let's say let's do continuous time domain. Let's put the square pulse at time A. Okay. In time domain, instead of the summation basically is integral of your whatever your signal is, x of t dot t. The output basically starts to accumulate over time. You slowly accumulate. This goes up to the point A. Yeah, this is point A. Then starts to decay, slowly decays. If you see here, your signal reaches to 0 at point A, but the output of your filter reaches to 0 at some point later on. And this is what this delay causes. Okay, so in discrete domain, when you have a bunch of discrete signals, if you take the summation of that with the some weights and some values, you're gonna have the same effect, but in discrete time domain. So the point that your signal reaches to 0, it will take time to output of your filter to reaches to 0, and that's caused this phase lag, the time lag. Phase shift in the frequency domain is time shift on the time delay in time domain. So because of that, we see this. Then the question is how we can solve that. Is there any way to solve that? The only way to solve this is to know information from the future, which is impossible. We should take a look at the type of systems that we have. The stock information, that information that we get real time from stock, we have information from past, from days ago, from years ago, up to today. We don't know what's going to happen in future. This type of systems or signals, they are called the quasi signals. They're signals that only the information available is information from past. The past is available. In order to overcome this challenge, you're gonna need information from future. Those systems are either non-causal. Basically, you have access to both future and past. Like if you have a recorded audio tape and you are in the middle of that audio tape, you have access to the past and future. Yeah, you can go back or go forward because the audio tape is already recorded. But in the real-time system, all of them are causal system. So if you apply a linear time invariant filtered like a IAR or the one that you see exponential moving average, you always gonna have that lag. So regardless of how you tune it, you're gonna see some time delay between the point that it crosses the slow and fast signals and the point that basically you see the change happens. The other type of signals that we have is anti-causal, anti-causal system that you have information only from future. Like in case of our audio tape, at the beginning, at very early on the audio tape, you don't have information from past. There is no information. You're at the beginning. All the recorded information are considered as a future. So something like that is anti-causal. For this stock, majority of these indicators, they have this sort of the summation factor. As you sum, you accumulate, and because the system is causal, you're gonna have effect of lag or time delay. So it's not a very proper way of trading according to that, to this, because you don't know when the peak and valley happens and when is the. You can go back and always check. Oh, maybe at the some point in time this is matches or not. Like what I have here for the SOXL with a 1 week period. As you see, still it's a discrete signal, but each discrete is represent 1 week. And in this week, for example, here I'm using MACD 3050 closing with the 26. So it crosses and goes to the bull market. As you see, the actual bull market starts from here, the 3rd of the month, and the crossing points happens 2 months later, 3 months later. So again, it's not a very precise indicator. Then all goes all the way up. You see lots of up and downs. Then you feel that, oh, there's a bear market and starts here. Maybe bear markets is finished there, but you don't know because of that effect. Okay, this is basically what I had planned to talk with you guys, discuss with you guys. It was effect of infinite impulse response, LTI systems on the infinite impulse response, and consequence of that as a basically indicator to do trading. I wish you best and see you tomorrow. Tomorrow we're gonna discuss about nuclear power and AI nuclear power and the future of the nuclear power and how we can trade based on that. Bye bye. See you all tomorrow.